We're going to move on to the exercises now for linear functions. So we're moving right on to word problems, applications. And for linear functions, this is the only kind of homework problem we're going to have is applications of linear functions. So let's start with exercise number 1. Now I hope in the video here I didn't recopy the whole problem by hand. I'm going to try to work from the handout and show the work on separate paper. So let's see how this goes. Number 1, the rent charged for a one-bedroom apartment in a particular apartment complex is described by the function r of t equals 150t plus 800, where r of t is in dollars and t is in years. T equals 0 is 2,000. So I recopied the function here on my piece of paper, and so we're using function notation. R of t stands for the output values, or the y values, and it's important to be aware of the units here. So the output values are dollars. And the input variable here, instead of x, we're using t. It's very common to use t in applications when the input stands for time. So here t is years. And notice that t equals 0 is 2,000. So 0 corresponds to 2,000. T equals 1 is 2001. T equals 2, 2002, so on and so forth. So let's go ahead and start working through the parts of this problem. A, what is the rent in 2000? Well, if t equals 0 is 2,000, we just want to know r of 0, which is 150 times 0 plus 800, and that's just 800. $800 is the rent in the year 2000. That's a monthly rent, so that's the way I'm thinking of this, $800 each month. And then we also want to know the rent in 2017. So for this function, I plug in 17, because t equals 17 corresponds to that year. 150 times 17 plus 800. And I went ahead and figured this out. You just pluck it into a calculator. I get $3,350. $3,350 is the rent in 2017. And for 2018, we want r of 18. And so we just keep plugging in here, right? And that turns out to be $3,500 is the rent in 2018. And we also want r of 19. 150 times 19 plus 800 is $3,650 is the rent in 2019. Okay. So there's part A. Part B is the question, how much does the rent increase from 2017 to 18, from 2018 to 19? So we just want the change. We're going to subtract to get that. Just what's the difference? How much did the rent go up from one year to the next? Now in function notation, the increase from 2017 to 2018, we can describe that as r of 18 minus r of 17 in symbols. That's 3,500 minus 3,350. 3,500 minus 3,350, that's $150, is the increase from 2017 to 2018. And if we want the increase from 18 to 19, that's r of 19 minus r of 18. And that's going to be 3,650. That's our r of 19 minus 3,500. And that's also $150. the increase from 2018 to 2019. Okay. Okay, so we got A and B answered. Of course, I think you probably already noticed that this 150 that we got here and this 150 that we got here is related to the 150 in the formula. That's actually the slope of the linear function that's involved here, right? So now in part C, we want to sketch a graph. And I'm just going to recopy the formula just so it appears on the screen here when I move the sheet of paper up. And I'm also going to write down some of these values that we've calculated in a table. Now instead of x and y, I'll write t, r of t, because that's sort of like my input-output, right? And we had 0, 800. Then we calculated 17, 3350, 18, 3500, 19, 3650. Now we have some large numbers here. We don't have like real easy numbers to plot. We're just going to approximate the location of the points that we plot. That will be just fine. We know this graph is a straight line because this is a linear function. So really all I need to plot are 2 points and connect them up. And it's probably a good idea to use 2 points that are furthest apart from each other. That just will make the picture look nicer. And I have my, really my y-intercept value is 0, 800. And then I want to get up to 19, 3650. Now, I'm got to set up a nice scale here. And I'd like you to think about that. Like drawing a nice picture with a consistent scale is a nice thing to do. And I'm using graph paper, by the way, so I can line things up nicely. Now, I want to go from 800 to 3650. I'm just going to count by thousands, and maybe I'll make 2 squares of thousands. So 1,000, 2,000. These are my output values, 3,000, 4,000. In this vertical axis, instead of labeling it y, I'm going to label it r of t values. Now going across horizontally, that's my t-axis. And let's see, it's okay here if I'm just going to go 5, 10, 15, 20. It's okay if I don't have a particular tick mark for the 19. And I'm going to plot 0, 800, 0, this would be 500 at this line, so I got to go up above that. 0, 800 is about there. And when it's nice to label the coordinates of that point, since we wouldn't know if we didn't label it, we wouldn't know exactly what it was. And then I just want to approximate the location of 19, 3650. So 19, 3650, it's close to 20. This is 3,500, so 3,650 is a little above that, right? And I want to back up a little bit because I don't want to be right on that 20. And then you just label it, so you tell everybody that's the point 19, 3,650. And those are the only 2 I need to plot. I can just connect them up with a line. And there's my graph of the function. Okay, notice how the axes are labeled nicely, 2 points are labeled. We have this linear function. Okay, and now I think there's one more part to this problem up above. I've lost here on the screen. It says fill in the blank. The rent increases by blank dollars per year from 2000 to 2019. So the part D the rent increases, and I didn't put it in the word problem, but we mean the monthly, well, the monthly rent, right? Well, I'm not even going to say anything. The monthly rent increases by $150 per year. For each year, from what is that, 2000 to 2019 is what we're talking about. And again, that, of course, that number right here is the slope of the line. I didn't say you had to say that, but that's the observation we want to make. 800, of course, is the y-intercept, or the vertical axis intercept. Now, there's one more statement here that I want you to see on the handout, because this is going to become really important to us. In applications, we don't really use the word slope when we're talking about something like this. We talk about what's called a constant rate of change. So in this problem, this $150 per year is the constant rate of change of the function. This rate of change idea is going to become more important as we go along. In fact, when you take calculus, some people will say calculus is the study of rates of change when they're not constant, and that's when it becomes a little bit more complicated. All right, we're finished with one. We'll go on to some more of these word problems in the next video.